morning, all of you. In this session, I am going to explain about failures in riveted joint and how to determine the efficiency of a riveted joint. Okay, this is the example for riveted joint. Now, before going to the efficiency of a riveted joint and failures of a riveted joint, first we have to know the fundamentals about the important terms used in riveted joints. Okay, the following terms in connection with the riveted joints are important from the subject point of view. Okay, first one is pitch of the rivet. Okay, it is the distance from the center of the one rivet to the center of the next rivet, measured parallel to the seam as shown in figure. It is usually denoted by P. Okay, here the pitch of the rivet. Okay, the distance between two successive rivets. Okay, the distance between center of the two successive rivets is called pitch. Okay, so here from this definition you can observe this is the one rivet, this is the another rivet. This we can observe this point is the center of the rivet, this point is the center of this rivet. Okay, the center distance between two successive rivets is called pitch. Okay, and also you can observe from this point to this point, this one also pitch. Okay, so the distance between two successive rivets is called pitch. Okay, and the second one is back pitch or row pitch. This is a double riveted joint, this is a single riveted joint. So back pitch or row pitch usually observed in double triple riveted joints. So it is the perpendicular distance between the center lines of the successive rows as shown in figure. It is usually denoted by PB. Okay, so here this is the center line of a one rivet. Okay, this is the another center line. This is one row and this one is another row. The distance between two successive rows of a rivets is called row pitch. Okay, row pitch or back pitch. Okay, row pitch or back pitch means the distance between two successive rows. Okay, the distance between two successive rows of rivets is called row pitch or back pitch. Okay, this is the one row of a riveted joint, this is the another row of a riveted joint, this is the double riveted lap joint. Okay, so here this is the pitch from here to here, the distance is pitch, from here to here the distance is pitch. In similar way, the distance between these 2 points is also pitch. Okay, so but here the distance, the perpendicular distance between the center lines of the successive rows, okay, is called row pitch or back pitch. Okay, and third one is the diagonal pitch. Okay, it can observe in zigzag riveting only. Okay, it is the distance between the centers of the rivets in adjacent rows of zigzag riveting. Okay, only you can observe in zigzag riveting. Okay, zigzag riveted joint as shown in figure. It is usually denoted by symbol PD. So here you can observe this is a chain riveted joint. Okay, here this one is a zigzag riveted joint. Here the distance between two centers of the riveted rivets, is called diagonal pitch. Okay, this is a diagonal pitch, and here this one from here to here the distance is pitch. From here to here the distance is pitch. and the horizontal distance between two rows is called back pitch. Okay, and last one is margin or marginal pitch. Okay, it is the distance between the center of the rivet hole to the nearest edge of the plate. Nearest edge of the plate, as shown in figure, it is usually denoted by symbol M. Okay, the distance between center of the rivet to the nearest edge of the plate is called margin. Here you can observe this is the center of the rivet and this is the edge, nearest edge of the plate. So the distance between nearest edge of the plate to the center of the rivet is called margin. Okay, so here this is the center line of the rivet and this is the edge of the plate. So the distance between center line and the edge, nearest edge of the plate is called margin. So this is the M. Okay. So this is the edge and this is the center line. So from here to here, the distance is margin. Okay. Margin usually taken by 1.5 into diameter of the rivet. Okay. And this is the another edge. So here from this edge to center line also margin M. Okay. So the distance between center line of the rivet and nearest edge of the plate is called margin. Okay. And the distance between two successive rivets are called pitch. Okay. Pitch means the distance between two successive rivets, and back pitch or row pitch is the distance between two successive rows. Okay, two successive rows of the rivets. And diagonal pitch is the distance between the two centers of the rivets. Okay, these four are the important terms used in our problems. So please remember. So you can observe this is a double strap diamond butt joint. Okay, and this is the single riveted lap joint. Okay, lap joint. This one also lap joint, double riveted chain lap joint. This one is double riveted zigzag lap joint. Okay, here in this diagram you can observe the distance between this rivet to this rivet is pitch, and here the distance between these two rows. Okay, these two rows is known as row pitch or back pitch. Okay, the distance between two successive rows is called row pitch or back pitch, and the distance between two successive center of the rivets is called pitch. Okay, here the distance between two centers of the rivets in successive rows is called diagonal pitch. Okay, here the distance from here to here is pitch. Okay, so this is the butt joint. Here this one is one plate, this one is another plate. Okay, to join two plates we are using one cover plate or two cover plates for supporting. Okay, so this is a single strap butt joint. Okay, single riveted single strap butt joint. This cover plate also known as a strap. Okay, this is the one cover plate and this is another cover plate. These two are the plates. Okay, to join these two plates we are using two cover plates. Okay, cover plates or straps. So double strap and single riveted double strap butt joint. Okay, this one also single riveted butt joint. So here this is the double row double strap chain butt joint. Okay, this is the double riveted double strap zigzag joint. Okay, now now coming to the important topic, that is failures of a riveted joint. Okay, failures of a riveted joint. A rivet joint may fail in the following four ways. First one is the tearing of the plate at an edge. Okay, by applying pull forces. Okay, the rivets may fail at the edge of the plate. Here you can observe. Okay, now I am applying the two pulling forces on the plates. Then this rivet may fail at the edge of the rivet. Okay, yeah, this is nearest edge. Okay, to avoid this failure, you have to provide minimum margin m equal 1.5 times the diameter of the rivet. Okay, this is the diameter, small d is the diameter of the rivet. And second failure is the tearing of the plate across a row of rivets. Okay, you can observe this is the failure across the row of rivets. When you are applying pulling forces, then rivets may fail across the row of rivets like this. Okay, you can observe this line. Okay, third failure is sharing of the rivets. Okay, here. So when you are applying the pulling forces, okay, rivets may fail due to shearing off. Okay, here you can observe this is the shearing. Okay, and fourth failure is crushing of the plates or rivets. Okay, this is the crushing failure. Okay, so these four are the important failures in riveted joints. For our design purpose, we are considering last three failures for determining the efficiency of the riveted joint. Okay. First failure, tearing of the plate at an edge. Okay, a joint may fail due to tearing of the plate at an edge as shown in here. This can be avoided by keeping the margin. Okay, by keeping the proper margin, that is m equal 1.5 times the diameter. Okay, by providing a minimum margin, you can avoid this failure. Okay, and second failure is tearing of the plates across the rivets due to the, here you can observe, due to the tensile stresses in the main plates. The main plate or cover plates may tear off across a row of rivets as shown here. In such cases, we consider only one pitch length of the plate, since every rivet is responsible for that much length of the plate. Okay, here you can observe this is the failure, tearing of the plates across the rivets. Okay, across the row of rivets. And third failure is tearing of the plates. Sorry, second failure. Here, the resistance offered by the plate against tearing is known as the tearing resistance or tearing strength or tearing value of the plate. Okay. Here, P, capital P is the pitch of the rivets. The distance between two successive rivets is called pitch. Okay, the distance between two centers of the rivets is called pitch. And here small d is the diameter of the rivet or rivet hole, and small t is the thickness of the plate. Okay, and sigma t equal permissible tensile stress for the plate material. Okay, now you can observe for pitch length, for design, for determining the tearing strength, you have to consider pitch per pitch length. So now I consider from this point to this point. Okay, here the plate. Okay, here this is the from here to here. This is the tearing area. Okay, so you have to consider the tearing area P minus D length into thickness T. Okay, this is the tearing area per pitch length. Okay, now tearing resistance or pull required to tear off the plate per pitch length equal to area into stress. Already we know the formula for stress. Stress equal to load by area, load by cross section area. So here you can observe tearing area. A is the tearing area and P is the tearing strength or pull required to tear off. Okay. Now sigma T is the tearing stress. So for determining the value of P tearing strength PT, then PT equal to stress into area. So area into stress is the formula for load. Okay, load or tearing strength. So PT equal to P minus D into T is the area, tearing area into stress. So this is the formula for tearing strength. It is very important for determining the efficiency of the joint. Okay, this formula is used for determining the tearing strength of the riveted joint. Okay, when the tearing resistance is greater than the applied force P per pitch length, then this type of failure will not occur. Okay. Now this is a third failure, that is a failure of a rivet due to shearing. Okay. So here you can observe when you are applying pulling forces on the plates, then rivet may fail due to shearing. Here you can observe this is the shearing. Okay. The plates which are connected by the rivets exert tensile stresses on the rivets, and if the rivets are unable to resist the stress, they are sheared off. Okay, they are shown in figure. Okay, here I am applying two loads. Here, two equal and opposite loads on the plates. When we are applying the loads, then the rivet may fail due to shearing. Okay, shearing of the rivet. It may be noted that the rivets are in single shear in a lap joint and in a single cover butt joint. Okay, for these two situations, we have to consider single shear. Okay, here you can observe only one failure, here also single failure. But in this situation, double strap butt joint. Okay, you can observe two places may shear. Okay, this is one place, this is another place. So we have to consider double shear for double strap butt joints. Okay, for lap joints and for single strap butt joints, we have to consider single shear. But for double strap butt joint, we have to consider double shear. Okay. Now this is the formula for area, shearing area. So this is the resisting area. Okay. So to resist this failure, this rivet must have proper resisting area. So this is the diameter. So already we know the diameter of the rivet, small d. So the resting area equal to pi by 4 d square. You have to consider pi by 4 d square for a single shear, that is the lap joints and the single strap butt joints. You have to consider single shearing area for these two cases. Okay, you have to consider pi by 4 d square for these two cases. For double strap butt joints, you have to consider double shear, that is a 2 into pi by 4 d square. double area. Okay. Now the shearing strength. PS is the shearing strength. So the shearing strength in single shear equal to n into pi by 4 d square into tau. Okay, n is the number of rivets per pitch length. That is, you have to consider n equal to 1 for single riveted joint, n equal to 2 for double riveted joint, n equal to 3 for triple riveted joints. Okay, so n into pi by 4 d square into tau is the single shear, n into 2 into pi by 4 d square into tau for double shear. But in practical, for design of boilers, you have to consider n into 1.875 into pi by 4 d square tau for double shear for boilers. Okay, don't consider 2 for boilers. Okay, this is the last failure of a rivet due to crushing. Okay, when you are applying the pulling loads, sometimes the rivets do not actually shear off under the tensile stress, but are crushed as shown in figure. Due to this, the rivet hole becomes of an oval shape, and hence the joint becomes loose. The failure of rivets in such a manner is also known as bearing failure. Okay, so here you can observe I am applying the pulling forces. Then this rivet may fail due to crushing. Okay. The resistance offered by the rivet to be crushed is known as crushing resistance or crushing strength. Okay. So for determining the crushing strength, PC is the crushing strength. Okay. This is the formula for crushing strength. PC equal to crushing resisting area into crushing stress. Sigma C is the crushing stress, and N is the number of rivets, and T is the diameter of the rivet, and T is the thickness of the plate. Okay, this formula is used for determining the crushing strength of the riveted joint. Okay, this formula also very important. Okay, so this is the crushing area. Now, efficiency of a riveted joint. The efficiency of a riveted joint is defined as the ratio of strength of the riveted joint to the strength of the unriveted joint, unriveted plate. Okay. So efficiency, this symbol is used for efficiency, zeta. Okay. The efficiency of a riveted joint is equal to the ratio of the riveted joint, strength of the riveted joint divided by strength of the unriveted joint. Okay. So already from previous discussion, the strength of the riveted joint, you have to consider least value of tearing strength, shearing strength, and crushing strength. Okay, tearing strength, PT is the tearing strength, PS is the shearing strength, PC is the crushing strength. So you have to consider least value of the PT, PS, and PC. Okay, divided by strength of the unriveted or a solid plate, that is a P into T into sigma T. Okay. Okay, this is the efficiency formula for riveted joints. Okay. For determining the efficiency of the riveted joint, first you have to determine the PT, PS, and PC values. Okay. Now coming to the example problems. Find the efficiency of the following riveted joints. A single riveted large joint of 6 mm plates. Here two problems are there. For first problem, you have to consider 6 mm thickness plate and 20 mm diameter of the plate. Okay, diameter of the plate equal 20 mm and thickness of the plate equal 6 mm. Okay, rivets having a pitch of 50 mm. Okay, here pitch P equal to 50 mm for first problem, and this is the diameter of the rivet. Diameter of the rivet is 20 mm. Thickness of the plates equal to 6 mm. But the problem is first problem is single riveted lap joint. Single riveted lap joint. Okay, and the second problem is double riveted lap joint. Thickness is same, diameter is same, but the pitch value is 65 mm. Okay, now take a permissible tensile stress, that is sigma T, for determining the tearing strength. PT equal to 120 megapascal, and shear stress, second one is a shear stress, that is tau. Tau equal to 90 megapascal shear stress, and third one is a crushing stress, that is a sigma C. Sigma C equal to 180 megapascal. Okay, these are the given values. So given data is thickness T equal 6 mm and the diameter of the rivets equal 20 mm. Sigma T tearing stress or tensile stress, sigma T equal to 120 megapascal. 1 megapascal equal 1 Newton per mm square. And shear stress equal to tau equal to 90 megapascal or 90 Newton per mm square. And sigma C equal to crushing stress 180 megapascal or 180 Newton per mm square. Okay. Now efficiency of the first joint. From given data, for first problem, pitch of the riveted joint equal P equal 50 mm is given. Okay, and thickness of the plate T equal to 6 mm. Thickness of the plate T equal to 6 mm, and the diameter of the rivet equal to 20 mm. Okay, so these are the given values for first case. Now you have to find out the efficiency of the riveted joint. So already we know the formula for efficiency. Efficiency equal to zeta equal to least value of tearing strength, shearing strength, and crushing strength divided by strength of the unriveted joint. So here first we have to find out the value of PT, PS, and PC. Okay, so here PT is the tearing resistance or tearing strength of the plate. Okay, already we know the formula for a tearing strength. PT equal to P minus D into T into sigma T is the formula for tearing strength. Already we know the value of pitch. P equal to 50 mm minus diameter equal to 20 mm into thickness equal to 6 mm, and sigma T equal to 120 megapascal. Already given in question. So sigma T equal to 120. So the final value is 21,600 newtons is the value of tearing strength, that is PT. Okay, PT equal to 21,600 newtons. Okay, and PS is the shearing strength or shearing resistance of the rivet. Already we know the formula, pi by 4 d square into tau is the formula for single shear. Okay, given question is a single riveted lap joint. Okay, for lap joints we have to consider single shear 1 into pi by 4 d square into tau. Okay, for single shear. So pi by 4 d square is the resisting area, tau is the shearing stress. So shear stress is 90 megapascal and D is 20. So the value of shearing strength equal to 28,278 newtons. So this is the shearing strength, that is PS. Okay, PS equal to 28,278. In similar way, The third one is the crushing strength, PC. PC is the crushing strength or crushing resistance. Crushing strength or crushing resistance. Already we know the formula for a crushing strength. That is the diameter of the rivet into thickness of the rivet into crushing stress. 180 megapascal is the crushing stress. So diameter equal 20 mm and thickness equal to 6 mm. So the final value is 21,600 newtons for crushing strength, PC. Okay, from these three values, PT, PS, PC, tearing strength, shearing strength, and crushing strength. First, we have to observe least value of PT, PS, and PC. So PT value is 21,600, PS value is 28,278, and PC value is 21,600. So the riveted joint may fail due to tearing or crushing. Okay, so the least value is 21,600. 21,600 is the least value. So for determining the efficiency of the joint, you have to consider least value of PT, PS, PC. So this is the least value, 21,600 divided by strength of the unriveted joint. So this is the formula for strength of the unriveted joint. That is pitch into thickness. Sorry, here pitch into thickness of the plate into tensile stress. Tensile stress sigma T. So this is the strength of the unriveted joint. Okay. So here P dash, you can take P dash. Okay. So this is the value of strength of unriveted joint. So you have to substitute this value here. Finally, we got 60% joint efficiency, riveted joint efficiency. Okay, this is the answer for case 1. Now coming to the second case. Here, in second case, the pitch of the riveted joint equal P equal 65 mm, and the thickness of the joint equal to 6 mm, thickness of the plates 6 mm, and the diameter of the rivet equal to 20 mm. Okay, diameter of the rivet equal to 20 mm. So by using these three values, you have to determine the efficiency of the joint. So, but this problem is a double riveted lap joint. Double riveted lap joint. So for a double riveted, you have to consider n equal to 2. For single riveted joint, n equal to 1. For triple riveted joint, you have to consider n equal to 3. Okay. This question is double riveted lap joint. So for double riveted, you have to consider n equal to 2. So this is the formula for tearing strength, P minus D into T into sigma T. Okay. So P equal to 65 mm, D equal to 20 mm, and thickness equal to 6 mm. Sigma T, tensile stress equal to 120 megapascal. So this is the value of tearing strength. That is PT. And this is the formula for shearing strength. PS equal to N into pi by 4 D square into tau. Okay, N for a double riveted joint, you have to consider N equal to 2 pi by 4 D square into tau. Okay, this is the value of shearing strength. That is P. Yes. Now crushing strength. PC is the crushing strength. Crushing strength PC equal to N into D into T into sigma C. Here N equal to 2. Okay. T equal 20 and T equal 6. Sigma C equal to 180. Okay, this is the value of crushing strength. Now you can observe PT value equal to 32,400, PS value equal to 56,556, and crushing strength equal to 43,200. From these three values, you have to identify the least value. Okay, least value of PT, PS, PC is 32,400. Okay, from these three values, you have to find out the value of least strength. Okay, here the least strength is 32,400. So now efficiency of the joint equal least value of the PT plus PC. Here the least value is 32,400. Okay, now P dash, this is P dash. P dash is the strength of the unriveted plate. Okay, this is the formula for strength of the unriveted or solid plate. P into T into sigma T. Okay, so this is the value of strength of the unriveted plate, that is 46,800. Here the efficiency is 69.2%. Okay, 0.692 into 100 equals 69.2%. Okay, this is the answer for second case. Okay, this is example problem. In next class, I will explain more problems on this topic. Okay.